So today we will be solving count special triplets. This was the problem, second problem of the Leetcode weekly contest 454. So what does the problem say? You are given an integer nums. A special triplet is defined as a triplet of indices ijk, where I should be less than j and j should be less than k. Right? Now what does the problem statement say? That nums of I should be 2 times of nums of j and nums of k should also be 2 times of nums of j. That means the middle element, let's say middle element, should be half of the elements which are on the left and the elements on the right. It can be at any position, right? Okay, so let's say let's take this example, right? So I've copied it already. Let's say what are the answer for this test case, right? For 4 we have elements on the left. For 4 what can be the elements? What will be the, let's say 4, right? The elements on the left should be double of this 4, right? So 8 should be there, and on the right there should also be a 8 at any index it might be, but these are the two. This is the valid triplet, right? So we can see this 8 is this side, 8 is also on this side, so this is a valid triplet, right? For a 2, what we need, for a 2 we need a 4 on the left side and a 4 on the right side, right? So here we can see this 4 and this 4 makes a valid triplets, and there can't be any more, because for 8 we will need 16 on the left and 16 on the right, and we don't have that, right? And for this 4 there is no element on the right, so that doesn't make any sense. So there are two valid triplets, this one and this one, so the answer will be 2, right? So that's what they are saying. And they have also mentioned, since the answer may be large, return the modulo of 10k power 9 plus 7. So what is the inference which you can draw, right? Let's say let me take this example once again to show you more clearly what I am thinking is, let's say let me paste it, right? So what does the problem say? The problem say, for this 4 what you have done is, on the left you search for a 8 and on the right you also search for a 8, right? So, and for this 2, right, what you did, on the left you search for a 4 and on the right you also search for a 4. So for every element, that is O of n, what you are doing, in inside you are going to the left and searching for the double of its value, 2 times that value, and on the right also you are searching for a 2 times of that value, right? And how many indices will also means how many elements you will get will also determine the answer. I will explain this part a later in this video, but let's try to understand what I am saying, what the time complexity will be of this code which we are thinking right now, right? So let's say on the right side you are also searching, so it will make it O of n into, for searching on the left and searching on the right, you will search on the left one, you will search on the right side, this will cost O of n, and thereby total time complexity will be O of n square, right? Now this will not fit in our time constraints. The time constraints given are 10k power 5, so we need to find a solution which is at least O of n or O of n log n. Any one might work, but you need to be inside S, and O of n square will definitely give you a TLE, right? So what should be the logic behind this? See, if somehow you already had a count of how many elements are on the right, which, and the count of those elements, for example, for this 4 what do you need, let me increase the opacity, right? For this 4 what do you need? For this 4 you need elements on the right which are 8. So what if you pre-computed all the elements which are on the right? Let's say for this 4 you already pre-computed it, map of 4 is 2, right? For this element it should not be 2, it should be 1, right? It should be 1. On the right side there is 1 4. How many 8 are there? There is 1 8. How many 2s are there? There is 1 2, right? Similarly for this one, you don't need to compute it every time, right? Don't get it otherwise. What you are doing is, you will first pre-compute all this map, right? You will map all those elements, right? Like map of 4 will be 1, map of 8 will be 1, 2 will be 1, and for this 4 also it will be 2, right? Ultimately it will be 2. When you will be traversing on this element, you will simultaneously remove this from your map. Means, let's say your map of 4 was 2, right? Now what you did is when you reach this element now, you will reduce its value by 1. So map of 4 will become 1, right? See, right side of 1, sorry, what I did. So it should be 1. So what you did, you can see after this element, the right side only 1 4 is there, right? Similarly, when you go on 2, what you will do, you will reduce the map of 2, and the count of those elements will still be the same, right? Map of 8 will be 1, map of 4 will be 1, and I'm storing just map of 2 is 1. It will get reduced after that, right? And similarly, map of 8 is 1 here, and right side 4 is there, right? And what you did map of, let's say when you were standing on map of 2 now, what you did, map of 2 minus minus, right? So it reduced the count of map of 2. So that should be the logic to compute on the right side, right? Now why I said now you need to find all the elements on the right, the count of elements on the right, and the count of elements on the left also. So what you can do is, you can from initially, right, let's say you will do map of 8 1, right? And when you are traversing on that element, you will side by side increment the counter, right? Map of 8 is equal to 1, map of 4, when you came on this integer, you did map of 4 equal to 1. When you went on 2, you had this map already, right? In that you added map of 2 plus plus, right? So map of 2 became 1. When you went on this pointer, what you do, map of 8 equal to, it's already 1, so it will get incremented to 2, right? So let me change it, it will become 2, right? And map of 4, which was already 1, it will stay there, and map of 8 will become, map of 2 is already 1, right? So by this you will save your time by O of n. Now you need to only traverse on the elements, and you will already have the count of elements which you needed on the left side and the right side, right? Let me explain this again if you have any doubt, right? Now see, you have the count of all elements, right? Now what you will do is, you will count, right, for 4 how many elements are on the left side, and how many elements are on the right side. Let's say there were 3 elements on the left side, and let's say there were 2 elements on the right side. Now how many pairs are possible? Think of this. Let's say 4 4 4, right? Middle element was 2, and 4 4 4. Now how many pairs are possible for this index 2? See, this 4 can combine with this. I have taken 2 here, na? So let me erase 1. Okay. So this 4 will combine with this 4 can combine with this 4 also. So this 4 will have 2 validities, this 4 will also have 2 validities, right? And this 4 will have 2 validities. So 2 2 2, which will be 6. So what I did was, let's say it had x on the left side, y elements on the right side. Y elements means y4, count of 4 on the left side was x, count of 4 on the right side was y. So total contributions will be x into y, right? So this will be added in the answer. So what will you do? You will traverse on the whole array, you will count the you will get the in O of 1, you will get the elements which are on the left side in O of 1. Similarly, the number of elements on the right side which are needed, you will get in O of 1, and you will simply multiply those elements. Thus your result will come in O of n, which is in your time constraints, right? So let's see the code for this. What I have did is, let's do this. So let's see the code right now. So what are we doing? First I am creating unordered map to count the elements on the right. So why are we starting from 1? Pretty basic, right? Because let's say we are standing on, if you will compute from till this point, then it does not make any sense, right? Because see, you need an element on the left, and if you start from this as your main element, how will you get element on the left? So that's the reason we are starting from 1, right? And we are going till n, and right of nums of I is nums of I plus plus. So for, I guess this is the easy part, right? Let's say 4, so map of 4 plus plus, map of 2 plus plus, map of 8 plus plus, and map of 4 plus plus. So map of 4 will become 2, right? So this is how right will be we will count the number of elements on the right? Similarly, we will create an unordered map left, and for that what we will do, first element map of left we will do plus plus, and from 1 to n minus 1. Now why n minus 1? Because on the right side you will come till this element only. You don't want to include this element as your middle element, right? Because that will cause, on the right side you won't get any element, right? So till, for that reason we are starting from 1 going to n minus 1. What I am doing is doing a right nums of I minus minus. For example, you are standing on 4, so you can immediately do a 4 minus minus, because this is not needed in your answer, right? So int double value will be 2 times of val. Val is what? Nums of I. So let's take this. So what is the double val? Double val is 8. So left में, right, I have used some Hindi names. So left में means कि left side में कितने elements हैं जो double है, left of double, right? So double was what? 8. So it will easily compute that left में for the first, this test case it will return 1, right? And right में means on the right side how many elements which are right double of 4, right, which is 1. So this will also return me 1, right? So what will be my answer? 1 LL. Why we are doing LL? Because answer can be very large as well. So we are doing one long value. How many elements are in the left? Which I already said, this was denoted by x and this was denoted by y. So x into y and doing a modulo of that, right, and adding this in our answer. And what we are doing? Left of nums plus plus. So if, let's say, when you are leaving this pointer now, you will go to this pointer, so you will need the left में 4 was also there, right? So you did an increment of left of nums of I plus plus and finally return the answer. So this was the code for it. The time complexity is big O of n, right? And space complexities we are using an unordered map, so O of n as well, right? So that's it for this video, I guess. If you have any doubt, you can definitely ask in the comments, and if you want any other solutions, you can also tell me in the comments. I will definitely try to bring it out. Okay, thank you for watching. Please do subscribe my channel.